Any subject, something that's confusing, didn't understand it, instructor didn't cover it well enough, or
what's next week?
Hmm?
Do you guys know what next
More review.
Is it with you or?
No, I'll be on the last review section.
Okay, so Thursday.
So, yeah, Thursday. Yeah.
Tuesday we have DTP, OTL, and ZBED.
DTP, OTL, and ZB is
Bruce, isn't it?
Bruce, yeah. And I don't know who OTL is.
That's Brent.
Brent, yeah, that's Brent, yeah.
Yeah.
And then DPT.
That's David Pitcher.
Oh, Dave Pitcher, yeah.
Yes.
Okay. So Pitcher, Brent, and Bruce. Next week, Tuesday. And they're supposed to be covering chapters 4 to 10, I guess.
Mm-hmm.
So what does your average day consist of being an amateur operator? Like you guys are obviously more into it than we'll start off being, but like is it just like anything else, like how we check email and stuff, you just tune in and see who's up?
It's whatever you want. It's a toy.
Yeah.
You
So
play with it or you don't play with it.
What do you generally use?
Well, I haven't used it in a while,
Okay.
but I have a fully set up station. If I want to play with it, I just turn on my power supply and tune into a frequency. Maybe I'll hear a conversation I want to do, or I'll call somebody. A lot of times I just listen and play around with all the fancy buttons on my radio that I forgot how to use.
So is it a lot less busy than it used to be back in?
Yes, it is less busy. Yeah.
So it's a lot harder to find people.
No.
There's still a lot of people.
There are lots of people. Yeah.
Yeah, well, just in general. Listening.
There's a lot of nets, particularly on 80 meters at night. There's net after net after net after net.
IRLP and call a different.
Yeah, you can get that too.
reflector,
Digital stuff
and
too.
usually end up with a bunch of people there.
But HF is the real fun. You know, tuning around, trying to pick the stuff out of the noise. And that's where the fun is. You know, turning the dials, pushing the buttons.
So if I was driving through the States with
Yeah.
a handheld,
Mm-hmm.
I'm not going to live there or anything, I'm just driving through
Yeah.
hours, whatever,
Mhm.
I'm allowed to use?
Absolutely.
Okay.
You're supposed to say whiskey 8.
Yeah, you have to identify. You have to follow the identification protocol.
Oh, okay, so I would...
Portable W8. If you're in Michigan, W9 if you're somewhere else. There's different. They have numbers just like we do. When they come over on our side, they got to say portable VE3 or VE2 or whatever province they're in.
Okay.
And then their tag after that?
And they do their call sign and then portable.
Okay.
And if it's Morse code, it's /VE.
How does that work again? I'm sorry. So if an American came over here, what would they have to do again?
Okay, if they're an American and they're operating in Ontario, they would go say this is W8 ABY portable VE3.
Portable VE3. Oh,
Yeah.
shows this on very.
Yes.
If you're going to Michigan, it's your
Portable
call sign,
W8 for us.
W8.
Yes.
All of Michigan is WA?
Yes.
Is it usually in one state for one code? Or
Yes.
Okay.
Yeah, they're different areas.
I'll get me some.
And that's available on the internet.
It's available on the internet, the different regions.
Get right into that.
And would you need to follow their, like, I remember reading someplace that from their code or the regulations, it stated that they had to broadcast their sign every 10.
You would have to.
So that would be, yeah.
You would have to follow all their rules
Right.
and not use any frequencies that you could normally use in Canada that are not allowed there. And you also could not use any frequencies that they use all the time that you're not allowed to use in Canada. So basically, you're limited to the lesser of your privileges or their loss.
Alan, good example of this is that we're allowed to use 220 megahertz here.
Mhm.
You can't use it in the Midwest.
No.
So you couldn't go over there with a 220 radio and broadcast right now.
Yeah.
But here you can.
And they can't come over here and use 220 megahertz because it's not allowed on the license. But if they came over here and they wrote a test and they got issued an amateur radio call sign for Canada, then they'd be considered a Canadian station. They whined piston moan to the FCC that they had to have these frequencies. They had lots of money, lots of lobbying, so they got this band wrested away from the amateurs.
Who was it? What company?
FedEx. They had to have them, eh?
Yeah.
10 years after they got the band, not one base station set up.
And then they just don't
So now what they did is they populated base stations purposely along the Canadian border so they can hold on to the frequencies and keep Canadians off them.
Oh.
Below the Canadian border area, they're not using the frequencies that they said they had to have. Yes?
You mentioned, like, you know, if you raw frequencies and that, and you said big ticket or something like that.
Pink ticket, yeah.
Like, what is the ticket? Like, if you
It's a ticket that comes from the FCC that states that you have violated a rule and regulation and you must pay to the cashier a certain amount of money or end up in court or whatever. Just like
it's an actual
it's a fine.
dollar value fine.
Yeah, FCC is big on fines.
What do they run at normally?
I have to check with the FCC. I don't think they probably not under $300 minimum.
Mayday?
Oh yeah.
Oh, Maydays
Mayday is 2,500 or jail time.
or both.
Or both.
No, it's the same with us.
Well, there's one in the.
We have two fines.
It says
We have two fines.
5,000 and 1 year in jail.
What if somebody is like impersonating somebody else? Like, is that a separate-
That may be that's
Is that
another
hard
legal
to
matter.
detect?
That's a legal matter.
Is that like hard for the FCC to detect, or can you have somebody like just running up fines in your side?
The FCC has a lot of very advanced tools, and we do too.
Okay.
But the FCC uses them a lot more.
Who are you with?
Industry Canada.
Okay.
Okay. The FCC uses fingerprint transmitter technology, which we have access to, but we hardly ever use it. What that basically means is that every radio has a specific electronic fingerprint. Every time you key the microphone, it makes it's like an electronic fingerprint. Rise and fall times, frequency of the background noise of the transmitter, characteristics, a whole bunch of different things, all of which can be mapped in like a fingerprint and can point right at that transmitter in a court of law. So yes,
Do they give off like a GPS location as well?
no, they do that with other things.
Okay.
I mean,
So
that's
they know their
basic.
radio
That'll be
tracking.
basic signal tracking, radio direction finding.
Okay.
How do you do that? Can you get into that? Like you mentioned the other day, how you guys did the Easter egg hunt.
I can go through that if nobody has any other
Yeah.
bigger questions. Or this isn't really on the test.
You hear it called frostments.
Radio frequency.
Do you
Tracking.
still do them often?
Yep, all the time. Yep.
Okay.
Okay, the modern way we do this stuff, we have a little programmable device, works on Doppler radio principle. It's a little box. We drop it on with mag mounts on top of our fully equipped mobile interference computerized signal tracking system. And it gives us a little indication, a little bar. It points right at the station we're going at. We drive all around and find it. So we can find any transmitter in this city within 10 minutes, minimum. Or maximum, maximum.
And is that
Possibly
all,
sooner.
Like, is that gear consumer?
Yes.
Price,
You-
the
you-
price range of consumers, or is it
Well,
expensive? So?
It's expensive. Depends who the consumer is. If it's a rich person, then it's
easy.
it's in their price range. But you don't need a lot to track radio signals. The easiest method to track a radio signal is with a rotatable dipole. And I built one out of a piece of wooden doweling. And do you remember those old back of the set rabbit ears that stick in the little plug in the back of the plastic case of your TV sets?
Oh yeah.
Yeah. Well, I stuck that right here. Use some electrical tape, fasten it down. Then you got your swing out pieces which are adjustable. Your ends on each side. And I just connect up the shield of my coax to one connection, center to the other one. I run it down to a BNC connection, connect it to my handheld radio, which has got a signal meter on it. Clip it onto there. Tune on the frequency I want. Then I determine the frequency that I'm going to track. I tune each one of these to 1/4 wavelength. So a total half wavelength across it. So for 2 meters, it's probably about this long. Then I just tune in the frequency I want. I just pick this up. I just take it away from my body and I just rotate it. The thing about dipole antennas have a sensitivity. They work like this. Maximum signal across the sides, minimum signal at the ends. So a rotatable dipole will have a null here and here, and it's very noticeable. You rotate that dipole slowly, your signal meter will go down to its lowest possible spot, maybe even come up, the signal will even be noisy, just for that little bit of spot. You note that. Draw a line directly parallel to your antenna. Then you move 90 degrees away from the point you just took your first reading, maybe a quarter mile. And you repeat it. You draw another line across your map. Where the two lines meet, that's your transmitter. The reason you have to do that is because you don't know which side the null's on. So you need two. It's called triangulation. Once you have the area, then you can just move into the area. You can still do your bit. It will actually null out as you get closer to the transmitter. It still works. And you can pretty well determine where the transmitter is. In the case of a handheld radio, you can probably determine what part of the house they're transmitting from. I actually used this method to find an illegal FM transmitter a few years ago. And I finished it off and I said, well, based on the signal and the location, the antenna system is in that room. And they said, nah. So the next day we went knocking on the business, and sure enough, there it was, set up on a tripod in that room. So,
What were they transmitting?
FM, legal FM broadcast transmitter.
Like
Low power FM.
Promotion for the business or just
They were retransmitting the transmissions of an internet radio station so that they could pick it up in their backyard. Can't do that.
You think they would have been smart if you knocked on the door and said it was right there in that room? Do you think they would be smart to take it away?
Well, they didn't know until I knocked on the door.
Oh, okay, so you told
There was nobody there at the time. I just noted it. We went in during business hours, showed them the card, said we're looking for a transmitter. We suspect it's over here in your building. And he said, yeah, as a matter of fact, it is. And so, do I need a license for that? Yeah, and a few other things.
Why couldn't he just get the digital radio? It just had no signal on his backyard, or
He was trying to use his regular radio to pick up his favorite station.
His regular radio. Oh, okay.
Yeah, regular FM radio. Thought he could do that, you know. Well, there's nobody transmitting in this band frequency. These guys are over here. This guy, I can do this. No, doesn't work that way. That's your simplest direction finding system. Cheap, works really well. To make it more interesting, you can also put in a little switched attenuator device where you could switch in 3 dB, 6 dB, 12 dB or whatever, and just sort of just flip the switches to cut down on the signal getting into the radio when you get real close, so you can determine if you're really close, because if you're still picking them up at full scale on here and you've got 12 dB of insertion loss, he's right there. He's real close.
That's just like one of those standard cable ones, right? The coax.
Yeah.
With the other.
Yeah. Basic signal finding. Next question?
So how did you even come about that? Somebody was just getting interference with their station, or?
Yes, we have a complaint.
Oh, okay. And that's usually how you discover these illegal transmitting.
A local broadcaster found a station on the air that shouldn't be there. He's paying a license fee. He's advertising for different people. There's a station that's not registered. It shouldn't be there. And he's right.
And the music part, that wasn't for ownership or royalty
Oh,
reasons. That's
that's-
just illegal in general.
That's just illegal in general. Broadcast stations have permission from the owners of the copyrights of all songs to do that. They
Oh,
obtain
no,
it.
I'm saying it's a public domain thing. You can't broadcast that over amateur radio. Can
No, you can't broadcast. We already covered this. No broadcasting of any shape and or form.
you? Okay, so it must be live voice.
No broadcasting.
No, sorry, like transmitting. I mean, like just so that you have like instead of me picking up the radio, talking, whatever.
Yeah.
You can't physically be making music or something as it's
No.
going.
No, you can't do that either. It's not for broadcasting. It's not, hello out there.
About antenna gain?
Yes.
Yes. This paragraph here confused me, I'm sorry, in the book. An antenna derives its gain by taking the power that would normally radiate in one direction and adding it to the power that is radiating in another direction.
Mm-hmm.
The total power radiated remains the same, but the power in the favored direction is increased by the addition of some power taken from a less favored direction.
Yes.
Not sure what that.
Okay, the best way to explain that to you would be by using a beam, for an example, beam antenna. In the case of a beam antenna, you have a reflector,
8-3. Yeah.
and you have your driver, and then you have one or more directors. Now what happens is you feed this antenna. This is where your power from your transmitter goes.
This is what, an array?
Yes, this is an array.
It's an array.
I'm giving an example of this. I mean, it works similar with vertical antennas, but it's easier to explain this way. Okay. So what happens? This is a dipole antenna, and they radiate the way I just explained it, right?
Yeah.
Okay. So here's what happens. This field also encounters this piece of metal. Okay. Any metal, when it's subjected to a radio field, has a current that begins to flow through it. It's just like your laws of magnetism and generators and stuff. That current, of course, is going to be at the same frequency as what it's being generated at, and it's now going to create its own magnetic field. That magnetic field will be weaker than this one because it's being generated from what it got there, but it will be at the same frequency, and depending on where it meets this field, it will be either in or out of phase. So it either will effectively increase the ability of this radiation in this direction, or it won't. Now this back antenna is deliberately detuned, so it's actually longer than the proper frequency, so that it won't radiate effectively. It'll actually dampen it. That way the antenna has lower gain here, so it doesn't pick up as much off the back, gives it selectivity. But this field encounters another element here. That element begins to radiate. These elements are spaced at the proper distances. There's a formula for it. And each one of those elements are arranged so that when they do generate a field, it's always in phase with this one. So they keep multiplying the effect. And basically you start off with a dipole that would normally do this. And by the time you multiply all these new induced lines, you end up with a pattern. It's more like that, and like this, because they aid each other. So that's how Yagi works, and your ground planes and that work in a similar manner, but it's easier to show you with the different elements. But basically, you have all these different magnetic fields, and they either strengthen or weaken each other depending on whether they're in phase. If the antenna is properly designed, then it will be in phase in the direction that you want to go.
Is there a limit to the number of director elements you can have?
At some point, you won't be able to get enough radiation to make it effective. But for example, I had an 18-element Quaggy, and that thing was impressive. I would feed that with 500 milliwatts of power, and I would key up the Pelston repeater. Full quieted, receive and transmit. This also works for receive as well.
So what was the power of it?
Effectively, well, it was 18 decibels of gain. So you have to calculate that out. So it's in 3 dB increments. So if you start off, let's say, I'll just go for 1 watt just for the fun of it, and we'll cut it in half later. Say 1 watt, you add 3 dB, that's 2 watts. Add 3 dB, 4 watts. Add 3 dB, 8. 3 dB again, 16. So we got 3, 6, 9, 12. One more. So 32 dB again. Yeah. 32 watts. 32 watts per 1 watt. So if you knock that down to 0.5, well, it'll be a little bit less, half of that, but still very impressive. Put 30 watts into that antenna. They're going to hear you really clear.
Put 170 in and see what happens.
Put 1,000. This is where your safety code 6 comes in. Now it's possible to exceed those safety code 6 limits, especially if you're pointing into somebody's picture window. That's why you want your antennas high above everybody. When you start dealing with gain antennas, you want them up there, so you don't run into that. Does that make sense?
Yes.
What are some common problems that most amateurs or some amateurs run into when they first start?
Problems.
If any.
Varies on. It depends on where you're putting your station. Sometimes it's getting a wire up in the air. What kind of antenna can you use? Are there any covenant restrictions? Do you want to draw attention to your operation or not? If you want to put in a significant installation, it'll take some planning. Maybe you might want to consult an engineer, or you may just look at websites that are made by the companies themselves, and they'll tell you what is minimal requirement for their product. If you're a first-time operator, you may have some problems making up your feed lines. Just putting the actual connections on your coax. It's usually a good idea to get the help of an experienced operator to help you set up your station. Because if you get these cables wrong and you short them out, you can blow up your equipment. So you really want them right. And not every amateur starts with the soldering skills to be able to put a connector on a piece of cable.
Always have a match meter.
Match meter's great. If you know someone that's got something even better, the analyzer we talk about, there's a few of those kicking around. I have one, and several other people have them. These things can be put on your antenna system without even putting any power into it. Find out the exact frequency, tune your antenna to exactly where it wants, no carrier on the air, perfect match. When it goes on the radio, it's done.
Where's the cheapest place to get an oscilloscope? Like, decent, run-of-the-mill?
Depends what you want to do with them. A simple oscilloscope, you get them on eBay, places like that.
Yeah, it's about 70 to $100.
Yeah, that's around the range.
That's what I was. Well, that's what when I was looking. But it might have been plus shipping because it was.
Yeah, there'd be shipping as well.
Yeah.
Is there a difference between the oscilloscopes?
Oh, lots of differences. There's dual trace, single trace. There's digitally triggered. There's just your old-fashioned analog versions. It just depends on what you want to do with them. What kind of sensitivity do you need? Are you going to work on solid-state equipment? Frequency ranges. Are you going to be working in frequency ranges that are above the range of most scopes? Typical scope is 10 megahertz, what they rate them at. If you're going to work on 100 megahertz systems, you're going to need a 100 megahertz scope, double the price of scope. Older scopes don't have three-prong plugs. Beware. Chassis is hot. Metal case, 2-prong plug. Beware.
Is there a place around here to buy them military surplus, like stuff like that, like oscilloscopes?
Not here.
In the States, probably.
In the States, there'd be lots of them.
One of my teachers
Toronto,
bought them.
all kinds of them. You can go down to Toronto, a place called Ford Radio,
Oh, okay.
and you can get all that stuff. That's where all our equipment goes. Ford Radio. Receivers, transmitters, test equipment.
Teacher I had did some contract work for the DOD, and he was in Ottawa, and he had a bunch. He said he had like, it was either oscilloscopes or something else. He had like 40, but I think
There's
it was
another big one
oscilloscopes.
there's another big outfit in Ottawa too.
Yeah.
Yeah, Ford Radio's the big one in Toronto. There's some bunch of ones in Ottawa. Of course, there'd be one in Ottawa. There's
Yeah, absolutely.
treasure trove of government surplus
Ottawa
electronic
was
equipment
really
there. Toronto, they have to ship it there, but Ottawa, it's already there.
I think that's where they run the auctions at.
Exactly, auctions. Yeah, you can get them online too as well.
Oh yeah, I guess an auction site, the government auction sites would have some.
Yeah, you can go right to the you can buy equipment directly from the government.
Yeah.
A lot cheaper than you get it at Ford Radio.
Oh, okay.
So basically,
Do you know the website for that, or you just?
You just government services, surplus. What do they call it? Crown assets. Just type in Crown assets.
Or just go to Google and type in.
And it'll be a Crown asset website. And if you want to get stuff, the best way to get stuff for that, you got to put in bids, eh?
Yeah.
And it's a good idea to be with a friend because the bids are usually on lots. They don't just sell a piece of equipment. So if you want a spectrum analyzer, you got to buy 10 of them. That's the bad news. The good news is that if you put in a bid for $100, you might get all 10.
Yeah.
Just depends on who bids against you.
Seen that with
If
computers.
Ford Radio gets them, he'll get them for 10. He'll get them for $100, and he will sell them each for $4,000 a piece to you when you go back.
So there's that much of a markup in some of the stuff.
That's what they're worth.
Wow. Oh, okay. So yeah. So it's just been.
They're being dumped by Crown Assets. They have no clue of what they're really worth. They
And
don't-
it's few and far in between for those
not
right?
that
No.
far between.
It's
Right
not-
right now would be a really good time. There's a lot of equipment being dumped.
Yeah.
Yeah, so they can make sure they buy it and spend all the money.
Yeah.
So they-
Our money.
Yeah, so they,
Our
so they
school
keep
picked up a
their,
$4 million laser.
so they keep their
Yeah,
income.
the stuff is out there.
Well,
You know where to look.
I guess in the 2000s, early 2000s might be good for that too, when all the surplus gear from the 80s and stuff.
There was some of that too, yeah.
Yeah.
But the department recently got rid of a whole bunch of older equipment. They moved to the new computer-based test gear. So there's a lot of that stuff that you're talking about is going to be available at rock bottom prices if you get them right from Crown Assets, but you'll be getting them in lots.
That's all full pool.
Yeah.
Yeah, that's so much.
Yeah, exactly. Yeah. $4,000.
That's
guys.
$1 club.
Yeah, dollar club.
Any other questions?
I saw a bunch of crown things from there.
Any subject to do with radios? Anything you didn't quite understand in your teaching so far?
Yeah, next week.
I'll be back on Thursday. The other guys will be in on Tuesday. There'll be 3 other guys.
Still 15 minutes.
Did I tell you the story about the Italian radio station in the Flower Gardens? No. I learned this from an FCC inspector who was visiting one time. You know how we were talking about how the radiation from antennas can get into things and cause audio wreck and other little things like that? Well, how many remember back in